Hey folks, we're going to get started here in just a minute. I'm just finishing setting up stream, so just hang tight and we'll start soon. All right, awesome. Thanks for y'all's patience. We can get going here. Let me just check this. Cool, looks like we're good. All right, as usual, feel free to pop a question in the Slack thread and we can go from there. I just put a little bit of instructions in there, so please, if you ask a question, please provide a link to the question and just include the number of the question so I can find it quickly, and we can make good use of the time today. I'm not seeing anybody asking questions at the moment, so we can just move on and go through the material. Wanted to do a quick recap. We covered the enumerate function, we covered list iteration. We got all the way through the lessons on list iteration last time, and now we're going to move to the accumulators section. Oops, let me actually move down into here. All right. So what is an accumulator? So by the end of this lesson, you'll be able to define an accumulator, understand the accumulator pattern. So we've talked about accumulator patterns before. Basically, it's where we start with, and this can be really any type. Could be a number. Quite often it's a number. Quite often it's a list. Those are probably the most common. But we can also accumulate into a string or even a tuple or a dictionary or a set. We'll say it's not as common to accumulate into sets. Generally, it's safe to accumulate into a list usually, and then turn the list into a set, right? So set accumulation is sort of related to list accumulation enough. It's just you can just cast it as a set at the end. But let's look at a couple of quick examples of accumulators. Let's do like a numeric accumulator. So let's say I have a list, and we'll say so I got this list. Let me actually make that a list. And what I can do is say for num in list. So this is my list that I'm iterating through. This is not my accumulator. So let's have an accumulator. We'll just have an integer accumulator, and we'll just count numbers that are greater than 5. So let's say if num is greater than 5, ACC, which is short for accumulator, plus equals 1. And then we'll print ACC at the end. So there are 5 numbers that are greater than 5, and we could change this boundary wherever we wanted. So for numbers greater than 3, we could look at that as well. And obviously there will be more. There's 7. All right, cool. So this is a really basic accumulator. It's kind of got just a taste of everything. So notice we have to have some collection of things to iterate through. This doesn't have to be a list. Quite often it is a list. It could be an enumerated list. Right, we could do this. We could do like a range len of the list. We could do something like that. And obviously I'm kind of changing the problem here. This code doesn't really reconcile with this code in the same way, but we could iterate through a variety of things. I'm just saying that there's a variety of things that we can iterate through in our for loop. So we need something to iterate through. I'm just going to iterate through the list directly. And then we need an accumulator target. I'll often call this the target because this is the thing being targeted for accumulation, right? When we do the act of accumulating here, let's say accumulation happens here, right? We're accumulating just the number 1 into the target, which is ACC, right? So this is a really typical pattern. There are some pretty wide variations on this, but basically, in general, you'll start your accumulator target with a 0 or empty target, right? So if this were a list, I would probably start with an empty list. If it were a number, I'll start it at 0. If it were a Boolean, I might start it at false or true. Really, there isn't as much of a canonical start place if it's a Boolean. It's sort of a stretch of the term accumulator when it's a Boolean, but there is such thing as Boolean accumulation. Yeah, or it might be an empty string or an empty dictionary, whatever, right? So we'll think about the accumulator starting at 0 or in an empty state if it's a collection of objects. Not all accumulation pattern problems will have that. Sometimes maybe there's like some seed of elements to start with That's not against the rules. Sometimes you'll start with something that is, filled out totally, and then you'll iterate through it and remove things. Some people will call that a decrementation pattern. You could think about that as a decrementation pattern, because rather than accumulating elements and growing something, you're decrementing, you're decreasing something. So this is possible with an integer as well. Let's say maybe we wanted to do 100, right? And instead of adding one, we could add one, but maybe we want to minus equal 1, right? So the pattern really has changed not at all, right? This is not a different pattern. It's just a different operation being performed. So in my eyes, I just use accumulator pattern to refer to this kind of problem as well, because even though we're decreasing something, we're not strictly accumulating, we're not adding, the pattern is still the same. So I will use the term accumulator pattern to refer to anything like this. So basically we just start a target. Usually it'll be at 0, or usually it'll be at an empty state, but it doesn't have to be, and that's important to know because there are times when you'll want to diverge from that. And then you'll iterate through some collection. It doesn't have to be a list. Often it is. Often it's a range. Often you'll enumerate. Sometimes you'll use zip. Sometimes you'll loop through a dictionary. There's a variety of things you can loop through. Almost always there will be some condition somewhere. Well, I say almost always. Very often there will be some condition. But often there won't be, right? So, maybe I just want to accumulate the sum of the squares of num. Oops, num squared. So ACC plus equals num squared, and this will be sum of squares. Oops, starting at 100, start at 0. Okay. So 330 is the sum of all these numbers, sum of the squares of all these numbers. So, there's a variety of things to do. So the condition isn't a necessary part, but I wanted to give an example with a condition in there, because very often you will have conditions that will tell you what and how to accumulate or when to accumulate. But sometimes you won't. And this is just, this is an integer accumulation, but we could do something like, let's do this, squares list. Excuse my shorthand here. Squares list. The plus equals actually would work for a list, but I'm going to do dot append because it feels a little more formal. Append. So if I wanted to take in this list and then make a list of all the squares of each number in the list, then I could say squares list dot append num squared print squares list. Cool. And that'll give me a list of all the squares of the numbers. Let's see, what else? What if I have mixed elements, right? Maybe I have like I'll just throw in some random strings. So we've just got a few random strings in here. So if I run this, we're going to get an error because num is no longer a num. It's really just an element now. It's an element of some type. It's no longer of type num. So let's change that to element. And we can't raise hi or hello to the power of 2. We can't do a mathematical operation on a string in that way. So what I could do is say if type L equals, I want to say int float. If it's in the tuple containing int and float, then we'll append the squared version. We can say lf type L equals, I'll just do this, n stir for string, list for list, TOPLE for a tuple, or set for set. If it's one of these, let's just do this, but we'll just get the len of L. We'll get the length of it and square the length, right? So that's something that we could do, right? So you can see here we have an if and an elif. I don't need the elif. I could just ignore the strings and not do anything with them. That's an option too. So whatever you need to do. So the accumulator pattern is important, hopefully for obvious reasons, but it's an important pattern. It's I've heard it sometimes called the everything algorithm, and it definitely feels like that at times. This is not true for every style or domain of programming, but I found it true in when I was doing full stack development, where I would have days where I would write a lot of code and just be day after day of coding, and then I'd realize at some point, like, gee, I feel like I'm just like doing an accumulator pattern. Like for most of what I'm doing is like writing functions with accumulator patterns, and then implementing those functions like wherever in my code base. So it definitely feels like something that you use a whole lot, right? In practice, the accumulator pattern is everywhere. There's a lot of problems that you can solve with the accumulator pattern. So yeah, it's a very, very important thing to learn, and I just, it's hard to understate the importance of it, right? There's there's a lot of little kind of topics here and there, and I don't want this to fall by the wayside as like another little thing. This is one of the big things. So, and it's one of the things where programming starts to, like, we're starting to synthesize all the elements, right? This isn't written in a function, although usually I would write this in a function somehow. But the sort of the very basic elements of a programming language are, or of Python, we could say, are functions, loops, conditions, and types, right? And the accumulator pattern is starting to bring all that together. We're sort of using everything together to solve a problem. So this is a common way, a common domain in which everything is sort of synthesized together. So it's a very important thing to understand. Okay, cool. So let's jump in. So yeah, so defining an accumulator, understanding the accumulator pattern, and I'm just going to kind of skim through here, see if there's any important notes, just read the things. Here's an example using string concatenation. It looks like we have this list of letters, which doesn't really need to be a list, it could just be a string. And then they're looping through the list of letters, and for letter singular and letters plural, phrase equals phrase plus letter. And this is just a list concatenation, or excuse me, a string concatenation technique to allow us to accumulate into this string. So this is a string accumulator because we're accumulating onto a string. So again, just to be clear about this, some of the terminology that I use, I call this the target, because this is the thing being targeted for accumulation. This is where the accumulation is happening. That is a term that I use. I'm not sure if other people would use it, just to be clear, but I like that term just because it sort of clarifies what we're talking about. But I've been understood by other programmers when I talk about an accumulation target, so you can use that term and people would probably know what you're talking about. Then the thing we're accumulating, or the thing we're iterating through, our iterable, is this list of letters here. And yeah, this is where our accumulation happens. And then at the end of the accumulation, we'll have the correct value for the phrase variable. Okay, cool. That's pretty straightforward. Okay, so true or false, the accumulator pattern can be applied to the following task. So given a list of numbers, find the total amount of even numbers in the list. Yep, and let's demonstrate that. So that's going to be true, and we'll prove it. So given a list of numbers, I'll actually just turn this into the right thing. So given a list of numbers, I'll take out the strings. So we just have a list of numbers now. Excuse me, gosh. Oh, great time to get hiccups, right? Right in the middle of the stream. All right. So we'll say num. Yeah. So let's call this number of evens equals 0, and we'll say if num mod 2 has a remainder of 0, if num over 2 has a remainder of 0, remember modulo gives us the remainder after doing division, so if, or after doing floor division, so if num over 2 has a remainder of 0, then we know that num is even. And then we'll say number of evens plus equals 1. And suppose we could do number of odds too. Why don't we just do that? Number of odds equals 0. So if it's not an even number, it's an odd number. We can just say else. So else being that if it's not even, it's odd. And then we'll accumulate to number of odds here, right? So this is just a variation. And this is a good thing to note, right? I have 2 accumulation targets in this pattern. And that's totally fine. It's not as common. Usually there will just be 1, but you can have 2 or 12 or however many you need. You can, and there's times where it really makes sense to do that. So it's not just academic, it's practical, like that you will encounter times where it really makes sense to have multiple accumulators. Like this, right? This makes this nice and easy. And this saves us from having to have a loop where we count evens and then another loop where we count odds, right? Oops. Oh, squares list doesn't exist, right? So we could print number of evens and number of odds. Cool. That's just proof of concept there. Okay, what will the value of x be after this accumulation code runs? Okay, so x equals 0, num equals list. This is a little bit informal the way this is laid out. Here, let me give an example. More formally, there's some kind of loose convention around this. It's a convention that I know just strictly from observation and experience. I've never seen this, to be clear, I've never seen this explicitly stated in any language specification, although it wouldn't surprise me if it is stated somewhere, and even stated somewhere in Python. But usually, so this has the accumulator target declared here, and then the list that we're iterating through declared here. This is not it's not immoral or anything. It's not wrong. It's not going to break the code. It doesn't really matter either way. But in general, like I said, this convention that I'm talking about is that your accumulation targets will be declared immediately above the loop, and that's what I prefer to do. Is to declare all my accumulation targets immediately above the loop in which I'm accumulating into them. And then that way everything kind of stays nice and tidy. It's just I follow that convention in my own coding, or I try to generally, just for the sake of consistency and having like consistent and readable code in that way. Sometimes I will forget and flip them, and it's really not a big deal. But I just wanted to mention that, and then this will often be like a parameter or something in a function. So that will run and give us x. So let's see. What will the value of x be after this code runs? So this is actually sum of squares. This is actually the exactly the code from one of the examples that I just gave above, right? So this says for num in num list, x plus equals num squared. So it's just the sum of squares. So I don't want to do all that in my head. So we'll just do this. 385, right? So that's 1 squared is 1, plus 2 squared is 4, is 5, plus 3 squared is 9, plus 5 is 14, plus 16 is 20, 30, et cetera, et cetera. So that's evidently all that together is 385. So. Okay. Let me just check my screen here. And I'm hoping I got my, actually I could expand this a little bit even. I got my text editor taking up most of the screen here because I think it's generally what we want to focus on, but I'm hoping that the my browser, the little section with my browser window is large enough to read and everything, so do send me a DM if it's too small though. Or I mean just post it in, just say, hey, can you make the text bigger? I can do that too. Okay. Okay. So let's complete this function. So def accumulate takes in chars, return an object that is the accumulated result of chars. So chars is a list of characters. Okay, and it returns a string. So we'll call this string, or let's call it text. Txt equals empty string. Start with an empty string. Notice this is not a string with a space in it. It's an empty string, so no characters in it. An empty string is a valid string in Python. Okay, so we start with an empty string and we say for, I'm just going to call it C for character, for C in chars text plus equals C return text. Cool. Oops, I don't know why I ran it twice. All right, and let's see what they did. It's called phrase for C and chars. Oh, that's interesting. They chose the same names I did. Yeah, same code. All right, integer accumulators. So I kind of covered integer and string and list accumulators all in a go here, but talk about integer accumulators as well. Also, I'm not seeing any questions. Do feel free to go ahead and put in a question if you're watching and you have any questions. All right, so by the end of this lesson, you'll be able to implement an integer accumulator, read and understand which code which implements the integer accumulator pattern, right? So there's not terribly much nuance here from what we just covered. So you know, it's just that we're starting our integer accumulator at 0 instead of like an empty thing. I guess 0 is sort of analogous to something that's empty, sort of loosely analogous. You know, they're showing mixed data. This I gave a really simple or really similar example to this, like where we wanted to only deal with the numbers in a list of mixed elements. They're using is instance in this case. I used type val in, and then I checked a list of elements that I was interested in, or a tuple of elements. But isInstance essentially does the same thing as type in the previous example that I gave. So yeah. All right. So since we've looked through a couple examples, I'm not going to spend a lot of time there. We can just jump in. So write the logic needed to loop through numList and accumulate the results of multiplying each number in an accumulator variable called prod. Careful on this one. Take care to initialize your accumulator variable. Okay, so prod equals. So remember how I said usually. Let's just do this. I'll do this in here. So we'll usually start something at 0, and I'll say for num in num list prod times equals num. Go ahead and see if you can see what the problem is with this. So if I run that code, what do you expect to see? You expect to see the rolling product here, right? But we just see 0. So why do we see 0? So let's look at this accumulation, the moment here where the accumulation is happening. Right? If we start prod at 0 and we say prod equals prod times num, num is 6, prod is 0, 0 times 6 is 0, so the next value of prod is 0, and then we go to 9, and then we say prod equals prod times num, num is 9, prod is 0, 0 times 9 is 0, etc. Right? So we're only ever going to get 0. If we say prod equals 1, then we start with prod equals 1 times prod times num, num is 6, prod is 1, so 1 times 6 is 6, and then prod is 6. So then the next time we get 6 times 9, and then the product of 6 times 9, which is, oh, I don't know. I'm not good with my multiplication tables. That's okay. But this will work. So we need to start prod at 1 in this case. All right. All right, so this says initialize an accumulator named result with the value 1000 and subtract the sum of the values in numList. So initialize the accumulator with result. Okay, we'll just call this result equals 1000 and subtract the sum of the values from numList. Okay, so we can say for num in numList result minus equals num. So this is what you could call a decrementation pattern, but you know, like I said, the pattern hasn't really changed. It just happens that we're subtracting something versus adding something. So you can use whichever term you like. Sum up only the odd integers from mixed data using an accumulator variable called oddsum. All right, so sum up only integers. Okay, so if I say odd sum equals 0 for element in mixed data, if type element in int float. I guess I don't need to include float, but only the odd integers. You know, it says specifically integers, so I'll just do this. I'll say if type L equals int, like that, and L mod 2 equals 1, that'll be an odd integer. Then I'll say odd sum plus equals element. Let's try that out. Cool. So hopefully it's clear what's going on here. I'm going through each element in the mixed data. EL is just short for element. If the type of the element is an integer and the element mod 2 equals 1, then we accumulate it. L mod 2 equals 1 tells me that it's odd. So that's why that's there. Interesting, let's actually look at this for a second. Something interesting happens here. This is something that I've realized I've done several times recently, that something that I take for granted, right? How do we know L mod 2, if it might not be an integer, how do we know this is going to work without getting an error, right? If I just do this here, I'm going to get an error because it's going to try to divide element, which at some point is not going to be divisible by anything, right? So it says not all arguments converted during string formatting. It's not a real helpful error here, which is kind of surprising. But basically, this is saying we can't. The error is happening because we can't divide hello by 2 and get the remainder. That's not something Python has a clear idea of how to do. So why can I do it here without throwing an error, right? You could maybe believe that, like, okay, well, if you do type, if you make sure it's an int and then you say if this condition, if that integer is over 2 equals 1, then you could say odd sum plus equals element. And this would work too. This would work just as well. But in this case, I can just cinch this up and make an and. And it has to go in this order, since the second condition on the right of the and is dependent actually on this first condition being true, right? So I can't actually do this in the opposite order, right? Like if I check if it's an odd number and then check if it's a number, right? Then I'm still going to get the same error. So this will give me an error as well. So the order is actually important, which is kind of a weird one. But the order is important even in an and like this, right? So first we check if it's an integer, and then we check if it's an element. So the operands for an and or an or will be evaluated left to right. And if this first condition is false, it's not even going to check this second condition, because we already know the and is false, because both operands of the and need to be true in order for this whole condition to be true, and in order for the and to give back a true. So if the first condition is false, it's not even going to bother checking the second condition. And I'm using that to my advantage, because the second condition will throw an error if the first condition is false. So it's a little bit, might feel a little bit dangerous, but it's just fine to do things this way. or at least I do them that way, so whatever that's worth. Cool. All right, float accumulators. Again, this is just a numeric accumulation pattern. We're just adding or subtracting, doing some modification of a variable, just like with int accumulators. We're just dealing with a float instead. So this lesson examines using an accumulator pattern with Okay, I don't need to go through this. This is just so similar to an int accumulator pattern. It just happens that you're using a float instead. So there's I don't think really too much of a nuance to be gone through here, but yeah. Okay, so for this challenge, initiate an empty list called running total. Okay. Equals an empty list. Initiate a new float called total. Oops. I could start this at 0 like this, but since it's explicitly stated to be a float, I'm going to start it at 0.0 because that is float 0. Iterate through numList, so we'll say for num in numList. Accumulating total plus equals num, and then we can say running total dot append total. I believe that's it. Correct. All right. Yep, that appears to be exactly the same code that I wrote. Okay, sum up the absolute value of the floating point numbers in mixed data. The absolute value of the floating point numbers. Okay, so we'll say yeah, I think we just square and square root for the absolute value. Yeah, that's what we'll do. Okay, so we'll say for element in mixed data, if type element equals float, we'll say absolute sum is the name of my accumulator here. So we'll say absolute sum equals 0.0, absolute sum plus equals L squared, oops, and then we'll square root to the 0.5. I think that'll give me the absolute value. Yeah. Okay, let's try it out. Cool, that works. And right, there's an absolute value function that I still forget exists. I got in the habit of doing this. Oh, I need the absolute value, so I'll square and square root something. But right after I submitted that, I was like, wait, there's a ABS function, of course. I'm just still in the habit of squaring and square rooting. It's a holdover from other languages. Cool. All right. So for this challenge, write code that will calculate the final average of numList and track the rolling average of those values in numList. The variable for the final average should be called numAverage, and the rolling average variable should be a list called rolling average. Okay, so we got numAverage equals, what is this, 0.0? I guess so. And rolling average equals a empty list. And we'll say for num in num list, oops, for num in num list, you know what, I need the index as well, and I'm going to enumerate. We'll enumerate and we'll say num average plus equals sum over num plus equals so let's call this num sum equals 0.0, and I'm going to say num sum plus equals num, and we'll say num average equals num sum over IDX, and then rolling average dot append num average. I think that'll do it. We'll see. Alas. Require another attempt. Okay. Let's read this error. Zero division error. Float division by 0. Okay, what did I do wrong? Because of course I can't. All right. So I actually need to start my enumeration at 1, because it's the length to that point, not the actual index. Okay. Yeah, so these two numbers are not the same at all. So what have I done? What have I done wrong? Assertion error. Mean.num average. Aha, okay. Okay, so I'm going to copy this into my editor here, and we'll go through it. So our average, and let me actually just get the average of this list. So I know that num sum should equal sum of num list. And I know that num average should equal the average of num list. So we can do that by saying, sum over len num list. Okay, so these two should be equal, and then these two should be equal, and then we'll just monitor rolling average, see what's going on there. Okay, so there's our rolling average. Ah, that's something. Okay, so it looks like our average is off, right? So I realize I'm doing this plus equals, and I don't actually need to be summing it. So is it? I think I just do divide equals? Equals num sum over, I think maybe I just do this. We'll try that. Num average, oh right, because the accumulation is already happening here. I was just duplicating that effort. So, yep, that fixed it. So all it was the num average. I don't need plus equals there. And that was because initially I thought, okay, I'm going to accumulate that directly into here. But I actually need to accumulate a sum separately. And then every time, say, the next value of num average is equal to num sum, and this is where the accumulation happened, right? So the accumulation already happens here, and this is an accumulation of sorts, but the the incrementation of the sum is already happening here, so I don't need to reduplicate those efforts. So this, let's see if this works. I think this should work. Cool, that works. And let's see what they did here. Num sum rolling average I. So I is in place of the of the index from enumerate. They're appending that num, and then they looks like they have num sum being calculated here every time, and then they calculate num average outside of the loop, and they calculate the rolling average every single time. So for me, that I guess those would be combined into one step where I calculate num average in the loop, and then just append num average, and then I end up with whatever the value of num average is. So different, 6 of one, half a dozen of the other, slightly different solutions. Cool. All right. So Boolean flags. So I mentioned this at the beginning, that you can have a Boolean accumulator. We'll usually call it a Boolean flag. The reason we call it a flag, there's this idea of like flagging something. I don't know, like setting or unsetting a flag as true or false. Something that has two states. So yeah, we'll usually call it a Boolean flag, but this is sort of what we call Boolean accumulators. I think I've had a lot of people express some frustration with getting through the Boolean flags material. Really, Boolean flags are very, very simple. I think the pitfall with them is that they're too simple. There's like too little going on here. I mean, all there is really to glean is that we'll do this. We'll say flag equals true, and then we'll say, for I in range, I don't know, 10, and we can say if I squared greater than 50, flag equals false. Or maybe we'll do flag equals true. right? So this will get up to, what'll it do? 8, and then 8 squared is 64, which is greater than 50. And, right, so this will swap our flag from false to true. So this is just a silly example, not really a realistic example, but there are cases where you just want to change a Boolean value from false to true, true to false, whatever, in your loop, and you can do that, and that's what there is to it. There is an interesting use for this. Let me see if I can give an example here. If we say, so there's something that I learned to call this a Boolean latch. It's kind of weird to call it a latch, but it's what I just know to call it for whatever that's worth. So what we can say here is, let's say if a given number is odd, we want to raise the next number to the power of the previous number. So we'll say for num in list. We can do a Boolean latch here. We can say if num mod 2 equals 0, then we'll say our flag equals true. And then we can say if flag, we need to do this in the opposite order. Yep, if flag num to the, let's do this, I'll raise this, print, so num to the power of previous num. And we need to make previous num exist. Previous num equals num. Okay, so and then we need to reset our flag. So we'll do that first thing here, right? Okay, so this is a bit odd, but this is hardly, we're hardly accumulating on the flag, right? It's just that this is a common way of using a flag that I've found to be helpful. So what's going to happen here is, first we're going to check if the flag is true, right? If the flag is true, well, we want to set the flag to false. We want to reset it to false. We'll make sure we get that out of the way. And then we perform whatever action we're going to perform here. Probably, maybe we would want to accumulate this into a list. Dot append this, and we can print our list down here. So we could accumulate into a list. We could print it off, do whatever we need to do, and it'll be good. Then we check if the current number in this iteration over 2 has a remainder of 0. And if it does, we set the flag to true. We capture that number in the previous number variable. And then we go to the next iteration, and then previous number is the number from the previous iteration. Since flag was set to true here, we've just passed that information to the next iteration of the loop. So flag is true now, so we reset it to false, and we append the thing, and then we check again if the number is even or odd, right? So what's going to happen here, we'll start with for, so flag is false, list is empty, for num in list, num is 4, remember. If flag is false, so we're going to skip this code. if num mod 2 equals 0, excuse me, this is gonna, I wanted to do if num mod 2 equals 1, then flag is true. So 4 mod 2 is 0 because 4 is an even number. So we're going to skip this and just move to the next one, which is 7. Flag is false. If 7 mod 2 equals 1, which is true, then we set flag to true. And previous number equal to num, which is 7, so previous number is now 7. Then we end that loop and we come up here and we say if flag, now flag was just set to true in the previous loop, then we'll reset it to false just to make sure we don't get into an infinite cycle. We want to make sure we reset our Boolean flag. Remember now num is 2, right? And then we can say list.append 2 to the 7th, which is going to be, what is it? 128. 2 to the 7th is 128. And then we'll check if 2 mod 2 equals 1, which is false. So we'll skip that code. Then the next iteration, we go to 8, and we check flag if flag is true. Now flag is false because 2 is not an odd number, and we didn't reset it to true. And we made sure to reset the flag to false so that we wouldn't keep raising to the power, right? So if I run this, we have a totally empty list. Okay. Why is that? Did I have this wrong? I must be not activating the second example here somehow. Yeah, that's an oddball. It's got me stumped. So let's see if we print num here, maybe that'll give us something. Well, let's print. Oh, huh. Okay, I see. Gosh, this is a silly error. The list that I'm iterating through and the list that I'm accumulating into have the same name, so I'm literally iterating through an empty list and not getting any iterations at all. So let's call this loop list, and we'll say loop list here. I was like, I just explained all that logic. It should work. What's happening? Okay. Cool. Very interesting. Okay. It's having a bit of a different behavior than I expected it to, but that's okay. Oh, right, because I changed this to 0 in an attempt to fix it. I was like, what's happening? All right. Gosh. Minor fiasco there. Okay, so that's what I expected to have happen, 128. Okay, so this is an example of a Boolean latch. If you don't end up confusing yourself by, renaming a variable with the same name twice and using it in multiple places, then it should go off without a hitch. Cool. Okay. Yeah, this is a good example too. Using a Boolean flag to control a while loop. Right, so when I write while loops, I tend to write while true like this. I tend to write my loops like this because I find it often like the heart of what you're trying to do is loop until you find something. So while true is just like, hey, just keep looping and I'll tell you when to stop, right? And then I think about a stop condition, right? So stop equals 100, and we can just say I equals 0, I plus gets 1, and if I greater than or equal to stop oh, I'm trying to do a Boolean flag. I'm sorry. Okay. Let's do this. So stop equals false, and then we'll say stop equals true or false whether I is greater than or equal to 100. That's going to be false. And then I'll say if stop break, right? So if we let's just print this off, print I, we'll print I. Cool, so that'll print I up to 100, and then we'll just break like this. This is a bit of a, there's a bit of a juggle happening here, but there are definitely times where having a Boolean flag to control your while loop makes a lot of sense. So this is an application for it, even though this is kind of a so-so example. But let's look at their example and see if it's any better. So done equals false, that's what I'm calling stop. X looks like that's what they're calling what I'm calling I. They have something more complicated going on here, right? So x equals 2 times x plus 1. Print x if x is greater than 10,000, or no, that's 100,000. Done equals true. And then that's actually controlling up here, right? While not done. So not done is not false, which is true. And then done equals true. Then that makes not true equal false, which stops the loop. So that's another similar example of what I just showed. Or actually, oh yeah, that's yeah, that is that would just be. I had an idea to change my example that might make it make more sense, but it was basically just the example that was given. Okay, cool. So when will this code break out of the for loop? All right, so nummod3 equals 0. So for num and num list, num modulo 3 equals, so when the number, the number is divisible by 3, what did I do here? Sorry about that. When the number is divisible by 3, so, number is divisible by 3. I'm not sure. First iteration, 12th iteration, never, 0, 1, 2, 3, 4. Fifth iteration, I'm not sure, is 79? 79 mod 3? Let's try that out. That's 1. I didn't think so. Maybe 38. 0 or 1, 2, 3, 4, 5. I don't think 38 is. I know 3, obviously mod 3 is 0. Okay, so that's 2. So I'm going to go with 5th iteration because I know it's definitely going to break out there. Cool. Okay, recall the code snippet from the previous challenge with one minor tweak. Numlist equals this, else divisible by 3 equals, interesting. Okay, so it looks like they're asking what will the value of divisible by 3 be after this loop ends. So just the only thing that matters here is the very last number, because it's getting a new value every single time. It's going to be assigned a value every single time. It's either going to be assigned true or false. So that means whatever the last value was is going to be the state of divisible by 3. 18 is 2 times 9. 9 is obviously divisible by 3. Cool. Write an integer sum accumulator that uses a Boolean flag to exit once the sum of numlist exceeds 500. Okay, so let's get down the easy stuff. Numlist equals 0 for num in numlist. Okay. If num is greater than 500, totally not on a trajectory to do a Boolean flag here. So if num is greater than 500, we want to break. Oops, I'm going to sneeze. Apologies. Sorry about that. I had a imminent sneeze that didn't go anywhere. Okay. So if num is greater than, what is it, greater than or equal? Exceeds 500. So 500 does not exceed 500. So we're going to do this. All right. Let's see. So I didn't use that Boolean flag. Let's see. How are they testing this? Write an integer sum accumulator that uses a Boolean flag to exit the sum of exit once the sum of numlist exceeds 500. The accumulator should be called this, and your Boolean flag should be called that. Okay, right. I have to read all of the things. Okay, we'll say this equals true, and actually we want to start this at false, because 0 does not exceed 500 yet. So I think we can just say exceeded 500 equals this, and then say if exceeded 500, then break. Let's try that. Oh no. Why? Why are you doing this? Very interesting. Wonder if it's inclusive. Wonder if they wanted. Int object is not iterable. Oh my gosh. Why am I doing this? What's my problem today? Num sum equals 0. Yeah, okay. Num sum plus equals num, and then we want to do if exceeded 500 equals num sum greater than 500. Okay, finally. There we go. Okay, I'm not sure. I was just forgetting all the things. I'm like renaming the list to an integer and then trying to iterate through it. So I don't know. That sneeze must have thrown me off. I'm going to blame the sneeze. Cool. Okay. So important takeaways for Boolean accumulators. It's a simple idea. You're trading a Boolean value from false to true at some point. This seems like, and let's see the example code they gave here. Yeah. So this is the example code they're giving. Exceeded 500 is being changed, but it's actually not playing a role here, right? So I took this to mean the way they said it. Write an integer sum accumulator that uses a Boolean flag to exit the sum accumulator, right? So in this case, I'm using the Boolean flag to gate this function, or this, excuse me, this condition. But really, it's just a wrapper for this value here, right? It doesn't even really matter. So either way, 6 and 1, half a dozen of the other, kind of. So yeah. So some of the ways that Boolean flags can be used can get a little tricky. I think the Boolean latch is kind of the best use case for it, because what it allows you to do is pass a true or false value to the next iteration of the loop, right? So you have something that happens in this iteration that informs something that you want to happen in the next iteration. That's when a Boolean flag can be really useful, a Boolean latch, right? But what you need to be sure of is that you reset the latch, right? So that the thing you do in the next iteration includes resetting the latch and then checking if you need to what you need to do with the latch and again. So that can be a little bit tricky, but that can be a useful pattern. The Boolean latch can be a really useful pattern. I actually, I admit that's a name that I call it because it's a pattern that I actually thought of, and I'm sure I'm not the first person to have invented it, but it was something that I found myself needing to do several times, so I just kind of gave it a name in my head, like, oh yeah, I'm building that latch thing. It's like a Boolean latch. And it was just a name that I thought of and that kind of stuck. So yeah, I think there is like latching logic, and I'm not sure that that actually conforms to what a formal latch is, but it might. It's just a name that I call it. So and I just want to note it because to me that's been sort of the most kind of pinnacle use case for a Boolean flag is in that pattern, whatever you want to call that pattern. It probably has another name, but I've never actually seen it covered anywhere, and I just bring it up because yeah, it's useful. Okay, list accumulators. So we've talked about these. You go through some collection, some range, some enumeration, whatever, do some logic and accumulate the appropriate item. Right, so here we're accumulating, it looks like if the number is even, if number mod 2 equals 0, it's even. So we're appending the squared value. If it's odd, we're going to append the cubed value. Here they're doing the same thing, just appending into two different lists, a squares list and a cubes list. Again, multiple accumulators is totally fine. This is something that I see sometimes people will be looking at a problem and kind of stuck against it and thinking like, I've literally heard people say like, oh shoot, if I could only have another accumulator, but I can't. And you absolutely can. So don't, just take that. I'm just going to take this opportunity to say, you do not need, you're not required to only have one. I think typically you will only have one, but it is by no means a rule that says you must only have one accumulator inside your accumulator pattern. You can have as many as you need. Cool. Okay, so here's another example. We loop through the list. We have a divisible by 3 list. And this is going to collect or accumulate all the numbers divisible by 3. So if num mod 3 equals 0, then num is divisible by 3. Then we just divisible by 3 dot append num. Cool. All right, on to the challenges. Collect all even numbers from num list in a variable called evens, odds. Okay, so there's our lists, and we'll say for num and num list if num mod 2 equals 0, evens dot append num. Oops. And then this could just be an else. There we go. Will that do it? Okay. All right, collect all the numbers from num list divisible by 3, divisible by 3, num list divisible by 7, divisible by 7. Okay, cool. So I'm actually going to just do this, or just copy my code from above. And just change the names. Okay, so, actually I'll do it in here. So if num mod 2 equals 0, we'll change that to 3. And then we want to do another one for our 7. And we say elif. And then we can say elif num mod 3 equals 0 and num mod 7 equals 0. Okay. We'll get rid of those. And then I'm just going to copy. Oops, I can't do multiple selections. Okay. Cool. So divisible by 3 here, divisible by 7 here, and divisible by both here. Okay. That should be it. I'm just doing this really fast, so there might be some errors, but we'll just check it out. Nah, yeah, I even got an error here. All right, let's see. Num list is not defined. Of course it's not. Because of course it's not. Let's pop that in here. I got an error in there too, so we'll see. We shall see. Looks like we got an empty list here and we were expecting some other numbers. That's very interesting. Second list contains additional elements. First extra. Okay. All right. So it looks like we were supposed to produce the second list and we got the first list. Okay. So let's actually read this. I probably did something incredibly silly. Oh, those aren't elifs. They're all ifs. Great. Okay, so here's a great example. I always look for examples. I am going to write this particular example down as an example for when to use consecutive ifs. And just in my sort of zeal of wanting to do this really quickly, I just defaulted to using elifs, and I need to actually use consecutive ifs, right? Oops. Let's do that right in here. Okay. Right, so this is specifically not elifs, right? Because a number can be divisible by 3, and a number can be divisible by 7, and obviously it can be divisible by both, right? So yeah, this'll work. So since each of these conditions does not exclude the other one from being potentially true, we need to actually run all the 3 of them simultaneously. And they're doing this with 2 loops, it looks like. They do 3 and 7, and then they run through one of the loops, or one of the lists, and check if it's also a member of the other list, and then append the ones that are to both. Okay. Finish writing the function divisors according to its docstring. Return a list of proper divisors of n, parameters, n, which is a positive integer, etc. Okay. Proper divisors. Okay. So proper divisors are just considered all factors that don't have, or all factors that aren't in itself. So I think 1 is considered a factor here. So what we can do here is we'll just have a list. Will be an empty list, and we'll say for I in range 1 to n, and I'm starting at 1 because I intend to divide by I. If I start at 0, I'm going to get a 0 division error. So we'll say if n over I has a remainder of 0, so n mod I equals 0. If n mod I equals 0, then we'll list dot append I. And since I'm not including n by saying plus 1, right, then, oops, that should work. Return list. Let's try that out. Now I'm not sure. Yeah, okay, that does work. I wasn't sure if a proper divisor excluded 1 as well, but yeah. Cool. All right. Nested list 1. All right, so I'm not seeing any questions. It is about time to wrap up, but we got one more here, and then we're done with this module. So, okay, so I just helped somebody with this earlier today. It's kind of a fun one. Okay. So these are really our tests, or a test actually. It's kind of broken out onto multiple lines, but that's okay. Okay, so for this, now we want to nest the elements. So this function takes in a list and then an index to start the nested list and an index to end the nested list. So we want our nested list to start at the end or at 0 and go to 5 here, right? So let's do this. Let's write a couple other tests here just to make sure that this is actually going to do what we want it to do. I'm going to do 2 more tests, and we'll say let's start this at 1, and we'll start this one at 1 here, and we'll end it at 3, right? So this should tell us what to do. Okay, so that tells us we want to start at index 1. We want this one to start at index 1 as well, and we want it to end at index 3. Okay, so these are the results that we should see, and this annoys me. Okay, cool. So a couple solutions for this. Let's just use some simple tools and do sort of a beginner solution for this, and then we'll look at another one. So we can say, let's see. Yeah, let's have our outer list equal empty list, and we'll have an inner list as well. And then I'll say for element in, what is it called, list 1. I'm going to rename these. I'm going to call this list. I'm going to call this lower instead of start index, and upper, UPR, for stop index. These are just shorthands that I use in all my coding. When I have a lower bound and an upper bound, I'll call it LWR and UPR, so I know what that means. So I'm using my own shorthand here. Stuff like this, as long as you're consistent. So we'll call this list. Okay, so for element in list, and I actually want to enumerate because I'm gonna get I need to keep track of the indices. So enumrate idx, and then we'll say if idx is less than or equal to lower, and idx is, oh, excuse me, this has got to be greater than or equal to lower, and less than, I don't know if less than or equal, I'll just do less than or equal for now, upper. Now I'm actually not sure about the bounds here. I might be a little bit off. I could think about it and try to brain it out, or I could just get Python to tell me, because I know what I expect for the inner lists. So for this first one, I should see 1 through 5. Next one, I should see 2 through 5, and then the final one, I should see 2 through 4. So if I print off element here, and these are, I should actually call this, let me call this num. That's a little nicer. Yeah, and we can see that that's what we're going to get. So 1 through 5, 2 through 5, and then 2 through 4. Okay, so this correctly isolates and identifies the correct numbers. Okay, so what we want to do here is, if we're in this range, we want to append to inner list. We'll say inner list.append num, and if we're at, and we could do this in a number of ways. We could do this if idx equals lower, then we want to actually append inner list to outer list. So we'll say outer list dot append inner list, and this will make sure that inner list is actually in there, right? So I've noticed there's a number of ways of thinking about this. I can either append it when it's equal to index, or when index is equal to lower, when it's equal to upper. And I can also do that at the beginning or the end. I'll just leave it here as upper. So once we're done appending to lower, we'll append it to upper. Or actually, I'll do it at lower. We'll do that. Why not? So once index is equal to the lower bound, we will append inner list, and then we will accumulate into inner list, and then we'll say else here. And this else bears on this condition. So if the index is not in this range, we will append to, you guessed it, outer list. Outer list. So here we have two consecutive clauses, right? So here's one if clause and here's another if clause. This has an if and else, but this is its own clause versus this. Okay. Then we'll say return outer list. Cool. So that should work, and I should see the appropriate lists. Oh, there we go. It's like, why is it not running? It wasn't scrolled down. Okay, so 1 through 5 is nested, 2 through 3, or 2 through 5 is nested, then 2 through 4. And that's what I expected. Okay. And then there's a pretty fun slicing thing you can do with this as well. Oh, no. No. Okay, list is not defined. Oh, right. I totally just changed the name of the parameters in my solution, but not in the function here. So I need to reconcile that as well. Oops. I hit copy when I meant to hit paste. That's great. Control C, now Control or Command V. There we go. Okay, that'll work. Okay, so now let's look at the fun way. Now this is a fine solution. If you solve this problem this way, that's fine. If this is what makes sense to you, that's fine. But I'm just gonna do this other way, just for fun. Okay, so what we can do actually is we can think about this as 3 slices. We can slice the beginning up to the appropriate bound. So we can start at the beginning and go up to the lower bound. Then we can start at the lower bound, go up to the upper bound. Then we can start at the upper bound and go to the end, right? And that middle section we can just put inside another list, concatenate all 3 of those lists together, and we'll have our answer. So what I can do is say list sliced starting at 0, right? So I don't need to put the 0 there, up to the lower bound. And I forget, I think this does not need to be, I need to think about this. I literally did this just hours ago with a student, but it doesn't matter because we're going to run it and test it here in a second. So I'm not sure if this needs to be inclusive or not. I think it does not need to be. Then we're going to concatenate into our inner list. And the way I know it's an inner list is I'm just going to put the slice inside square brackets, which is going to nest it in the list. So in this case, we want to start at lower and go up to upper. And then we're going to concatenate that nested list with list sub. We'll start at upper and go all the way to the end. So this should do it. I might need to adjust upper or lower here. We'll see. I think I will. Aha. So this is a little bit off. These are the nested portions of the list are all, they all end 1 index too early. So I just need to push it 1 further. So, oops. So this nested list needs to be moved up to 1 index, right? So if I run that, that actually tells me that I'm going to have to do something to upper as well, because I think that's going to be duplicated. Yep. So this is, notice I have whatever that index, that upper index is duplicated in here. It's in the nested and the outer list. So I think I just need to start 1 later. So I just need to add 1 to that. And that should do it. We'll see. Yep, and that does it. Cool. So this is something that I see. The reason I show it in this way is this is something that I see people like spend a lot of time on. Like, okay, now let me make sure I get all my indexing correctly and think through it properly before I run my code. It's just not that fast to do that. After a couple years of programming, number of years of programming now, um, if I sit there and try to brain it out, like sure, I could do it. I could think about it. But what I do with indexing, I just think about, I just kind of take a mental note of every place that I'm using indexing, and I try to get something up and running to the point where I can test it and then adjust the indices based on my tests to make sure everything's working. So I always, if I'm doing any serious coding at all, I always have tests in place to give me a signal about whether things are working or not, because I can, and this is my thing. I speak for myself, but I notice this in other people as well. You can be perfectly smart and spend a lot of time making sure all your indices are correct and everything's working and gonna be fine, and then still get it wrong. Um, so the only thing that really gives you a signal about whether it's working or not is, did you put it to the test? Did you run it? Did you verify that you're getting the result that you think you should be getting, right? So having tests in place is really gonna it's really the way forward either way, right? So just as a tip, you can just think about the places where you're doing indexing, and just come back to that once you run your code. And you don't want to accumulate a ton of those before you run your code. So 2 or 3, and then run your code, and then just make the little micro adjustments. Add one where you need to add one, take away adding one where you don't need to add one. Maybe you need to subtract one. I don't know. So things like that. So that's just a little pro tip to help you solve those problems faster. You can offload the responsibility of verifying those little details onto Python, and it'll do fine. And then, of course, let's just verify that this will work, just to prove that it works. Run it against the actual tests here, right? Cool, that works. Awesome. Well, cool. Thanks for everybody who was watching. I didn't see any comments or questions today, which is kind of too bad. Hope everybody knows that yeah, that's really the main purpose of Study Hall, is to be a venue for people to ask questions and have me go over them, and have you all talk about them and bounce ideas off each other as well. Hope this was helpful. I always have fun doing these, and look forward to the next time. So I'll be streaming next on Monday, and look forward to seeing you all there. Yeah, and go ahead. I got to give the obligatory YouTube speech. We're trying to grow the channel, so like, comment, and subscribe helps. All that is helpful. We'd appreciate that, and look forward to seeing you next time. Cool. Bye bye.